Okay, welcome to a brief video on using the TI solver for an AP type calculator active question on the AP calculus exam. So I made this question up just to show how to use the solver on something that can be otherwise kind of difficult. So I took this function and I said, suppose you are asked to determine the C value which satisfies the conclusion of the mean value theorem for function f of x equals 0.5 x squared e to the negative 0.0025 x squared over the interval 0 to 5. So if you remember what the mean value theorem says, first you have to make sure that you state that f is continuous and differentiable over that interval. And we can kind of see that it's differentiable since we have x squared and an exponential function, the product of those two. I would just state that and not worry about proving anything, but most times you'll be told it's differentiable and you just have to state it again. So this problem, since it's asked to find the C value, it essentially is asking you to find where the slope of the tangent line to f is equal to the slope of the secant line joining the endpoints, or essentially where f prime of c is equal to f of 5 minus f of 0 over 5 minus 0. So that looks pretty easy right there, but as soon as you start putting the function in, boy, that is not going to be that nice to solve. So you got the derivative of that nasty little product up there between x squared and an exponential equaling some number. Now that under algebraic conditions, this equation, this expression on the left involves an x squared and an exponential. To solve for x, you would have to use some technology. It can't be solved using traditional undo algebra techniques. So we have to use technology. So we're going to use technology pretty efficiently. And just remember that the AP doesn't expect to see a lot of solving, really, or any manual solving on the calculator portion. They assume you have a calculator which does this kind of thing. So I have my calculator, my TI-84, queued up here. I'll get the problem handy again. So we want to find where that, the C value, where that nasty function right there has a slope of the tangent equaling the slope of the secant line joining those 2 points. So the first thing that I did was I put my function into y1. So there you see my function, okay? And we might as well take a quick look at the graph of that, as long as it's in. It's a little slow because it is a product of two types of functions. It looks almost parabolic, which isn't too surprising given that first term of x squared. But I want, if you remember, essentially I want to solve this equation where f prime of x is equal to that secant value, or the slope of the secant line. So the next thing that I'm going to do is I'm going to go into my solver menu, which is under math, and I scroll down to find my solver menu right there in B. So I hit solver. This solver menu has expression 1 and expression 2 that you're going to set equal. So I want the derivative of that function first. So I'm going to go find my derivative, the numerical derivative with respect to x of that expression in my y1. So I'm going to use my vars key right here And I'll scroll over to y-vars and function and select y1. So I'm going to find the derivative of y1, and I don't know what point, so I want the whole derivative at every value of x. So I'm going to say x equals x. In the expression 2, if you remember, I want the slope of the secant over the interval 0 to 5. So I'll just make the calculator calculate that and go y1 at 5 minus y1 at 0. Oops, forgot the parentheses there. At 0. Make sure you use careful parentheses. Divided by 5 minus 0, which is just 5. So I'm going to set the derivative equal to the slope of the secant, and I hit OK. All right, so now it shows me this is what I'm solving, the derivative of y1 equaling the slope of the secant. Now notice the bounds. This tells me it's going to search for an answer between -1 times 10 to the 99th and 1 times 10 to the 9th. It's a very large search area. If you want to reduce the search field of your calculator, you can change this. You can say, oh, please only look between 0 and 5. Okay, where's my brackets again? Darn it. I have to remove this just for a second to find where I lost them. There we go. Okay. They were, by the way, above the parentheses. So if you lose your brackets, you gotta retype them in there. Maybe it'll take it without that right one. Then you scroll up to where X is, right there. And you tell your calculator using that button right there. So it's green. You gotta hit the green button first, the alpha button first, while it's on there. And by the way, your calculator tells you right here, select the variable and press alpha, solve. So I've pressed alpha, then I hit the solve. Whoops, bad guess. Ha! It might tell you that. It was 10 and I didn't change that setting, so I really have to guess in between 0 and 5. All right, so I'll guess maybe 2. All right, and then I hit alpha, solve. And you'll notice that it's thinking for a little while up there, and it tells me 2.418. Now remember that anytime we use a numerical method to get a value in calculus, we have to know how close that numerical value is, and your TI tells you that this is how close expression 1 minus expression 2, so this side minus that side, is really close to 0. So I'm going to use 2.4184. If I quit for a moment and I hit my X, that is the last value that your calculator stores or has in its memory for X. So I am going to then store that so I don't lose it next time I do something. I'm going to store that. Let's store it for alpha A. All right, so now A is that. Now just to be really convincing, I'm going to double check and say, well, what is the value of my derivative of y sub 1? Okay, derivative of x of what variables y sub 1 at alpha A. Whoops, I guess not there. I don't need that there. Sorry, forgot about that. I'll put it there, alpha A, and delete that stuff. Delete. I want a variable in there. Maybe I could put x, I suppose, but I'd probably just need y sub 1, but I'll put x. And I get the fact that y sub 1 has a derivative value at A of 2.348. Now let me see what that secant slope is. And so I'll do y sub 1. Oh, insert parentheses though. Did I insert? Yep. Y sub 1 of 5 minus y sub 1 of 0 divided by 5, and then my face will be red if it's not 2.348. Oh, God. So that tells me that my derivative at this point is equal to the slope of the secant there. And that's probably the most efficient way of using the solver key in conjunction with the derivative to find an x value or c value satisfying the mean value theorem. I hope you enjoyed this short video on how to use solver in a very otherwise technically difficult problem.